Hi, this is Øystein, and this lecture is on significant versus relevant findings, fishing for p-values, and a little bit on how to present and interpret multiple estimates that you may get from your analysis. This is the outline, and as you can see, we'll start by talking about significant associations, and then move on to what is meant by relevant, by a relevant effect. Uh, these two subjects sort of belong together. Then we'll see some examples of how large data can be used, or rather abused, to get whatever results you wanted by fishing for p-values. And finally, we'll talk a little bit about what we need to think about if we conduct more than one test in our analysis, which is quite common in register epidemiology. Okay, like I said, we start out by looking at significant associations. This table shows the risk of having a child with low birth weight, which is defined as below 2.5 kilos. We want to know if the risks are the same in Finland and Sweden. The first row shows the risk in each country for 1 year. The next is the risk in a 5-year period, then 10 years, 20 years, and 40 years. And by the way, I simulated the data, but the real data would look a lot like this, probably. Considering the top row, we see that the risk estimate is a little bit higher in Sweden, with a risk ratio of 1.008. So this is the risk in Sweden divided by the risk in Finland. And these numbers are percentages. Still, looking at the p-value, we get no difference between the countries. The second row also shows no difference, but now the risk ratio is flipped so that the risk in Finland is higher than in Sweden. By the way, you would probably never create a table like this if you had access to 40 years of data, right? You would just use the last line. I show you this because we don't always have a full data set. Maybe, for example, there were ethical aspects or other reasons why you were not able to get more than a few cohorts. Maybe you had to merge data sets from different areas and you were left with only a few cohorts, for example. Anyway, if we have 10 cohorts, we are able to detect that there is indeed a statistically significant difference between the two countries. The risk of having a low birth weight child is lower in Sweden than in Finland. In this case, using more than 10 cohorts does not change much regarding p-values and estimates. But still, yeah. So we can conclude that the risk of having a low birth weight child is about 2.5% lower in Sweden. And we get 2.5% by taking 1 minus 0.975, right? The bottom row. It doesn't show in the table, but the lowest p-value is really low. So the p-value in the bottom row is really low. That obviously changes as we get more data, right? The p-value gets lower and lower. The association between risk of low birth weight and country of birth is super significant, right? But what does this mean? Again, the risk was 2.5% lower in Sweden. About 2,580 children are born with low birth weight every year in Finland, suggesting that about 65 children would have been normal weight if the risk had been like in Sweden. I'll explain this one more time, a little more slowly. If you take 2.5%, so that's the risk reduction from Finland to Sweden, So 2.5% of 2,580, you get about 65. So therefore, if you reduce the risk of low birth weight by 2.5%, that would be the same as reducing the number of low birth weight infants by 65. So what are the implications of that? Is this finding important? And are the results even trustworthy? And you can shout your answers at the screen if you want to. I'll give you 5 seconds to do that. Okay, regarding trustworthiness, let's assume that low birth weight children are given extra attention at the maternity ward, right? This may give midwives an incentive to round down the birth weight, so to speak. So if you feel that a baby will be cared for better if you write that the weight is 2,495 grams, but the true weight was 2,505 grams, you may think, okay, it's not the true weight, but this child could benefit from the extra attention a low birth weight child would get. This wouldn't make you a bad person at all, but it would affect the rate of low birth weight children in the birth registry. Babies with birth weights that are just above the 2.5 kilo cutoff would have a tendency to have their weight reduced in the birth registry if this was happening. Still, that should affect children in both countries about the same, right? There's no reason why the Finnish midwives would behave differently than the Swedish midwives. Unless, for example, the handling of low birth weight children in Finland is a little bit better than it is in Sweden. Now, this would provide Finnish midwives with an incentive to round down the weight that is a little bit stronger than that of the Swedish midwives, right? So we may have that the risk in Finland appears to be higher because their system is better. Okay, so we don't know that this is the case. It's purely hypothetical, but any such difference between the countries could affect the risk ratio estimate, right? And other effects that were similar or slightly different. Further, even if we assume that the results are trustworthy and the risk in Finland is 4.3%, whereas in Sweden it's 4.2%, then what? 2,500 grams, 2.5 kilos, is just an arbitrary cutoff, right? So this probably means that there are slightly more babies in Sweden who weigh just above the cutoff, and that the 65 extra low birth weight babies in Finland were probably just below. I mean, it's unlikely that the Swedes have come up with a system that gives almost exactly the same results as in Finland, except that 65 children who would normally be 1.5 kilos or something like that at birth now are 3.5 kilos. It's much more likely that such a system would yield a small gain. So perhaps we would observe something like this if if the small Swedish babies were 10 grams heavier than the Finnish on average. And if so, the difference in health outcomes between the two babies of 2,495 grams and 2,505 grams is probably negligible. Or at least it has very little to do with the 10 extra grams. The health effects of such a small difference would be dwarfed by the effects of other things, such as lifestyle or genetic effects. Still, when we have millions of observations, like we often do in registered epidemiology, we are able to detect these tiny irrelevant differences. We could have detected differences that were much smaller even. Now, what if the outcome was infant mortality rather than low birth weight? And about 65 fewer infants would die in Finland each year if Finland adopted the Swedish system. Would this be more important? And again, you can shout your answer at the screen. I'll give you 5 seconds. I would say yes. Death is a much more serious outcome than low birth weight, right? Would it be more trustworthy? Again, I would say yes. For example, death is impossible to round down, right? The child died or it didn't die. Still, adjustment for other factors such as maternal age or lifestyle could flip the effect, right? So there could be differences between the countries that would, so that that there was a good reason that more children died in Finland. That had nothing to do with the healthcare system, for example. So even if we do detect a statistically significant association that we also deem to be important, it does not mean that we should necessarily call the press immediately. But in this case, the Finns should probably try to figure out if the Swedes are doing something that the Finns are not. Okay, so this figure shows two things. The empty circles over here show the rates of sudden infant death syndrome, or SIDS, in Norway from the late 60s to the early 90s. And these numbers are from the birth registry. The full circles, these guys, show the proportion of infants sleeping on the belly, or what is called the prone position. And this information is from questionnaires. The scales are different, so you have to look at the left axis to read SIDS per 1,000, and the right axis shows prone sleeping position per 100. So that's here. So you see this is 55%, and this is 2.6 per 1,000. As seen, the risk of SIDS increased manifold from the 70s through the 80s. And the same did the proportion of babies sleeping in the prone position. My understanding of that increase in the prone sleeping position is that mothers were told that this was good for the development of the baby's back and neck strength. I wouldn't bet my house on that statement, though. Of course, now parents are told that it's great to have the baby in the prone position as long as somebody is watching carefully. So don't leave the baby on the belly. Now, from January 1990, parents were advised to avoid prone sleeping. Especially the mothers were advised to avoid putting the baby on the belly. And we see that the number of deaths were halved from about 2 per 1,000, that's this area, to about 1 per 1,000. And in Norway, this corresponds to a reduction of about 60 deaths per year. So overnight, they gave this advice: stop putting the baby on the belly, and we see that mother stopped doing that. We can see that from the black dots here, that they actually stopped doing it from the questionnaire data. And then we see at the same time, about half of the SIDS cases were happening. And this corresponds to a reduction of about 60 deaths per year in Norway, which was a huge discovery. There were similar campaigns in Denmark and Sweden as well. In this case, in this figure, the top curves over here show total post-neonatal deaths per 1,000, and the bottom curves down here show SIDS per 1,000. So you see the Swedes were always lower than the Norwegians for some reason, even before they started this risk reducing campaign. The arrows point at the start of the risk reducing campaign. So this was January 1990 in Norway, like I said, December 1991 in Denmark, and spring 1992 in Sweden. And as you can see, the SIDS rate starts dropping immediately after the campaign in all countries, right? You have this upward trend, and then boom, starts dropping. Upward trend, boom, starts dropping. Upward trend, or at least not downward, and boom, starts dropping. Thousands of infants have been saved over the years because of this. Now, our topic is significance versus relevance. And these were small absolute reductions, right? We're talking 1 or 2 per 1,000. Still extremely relevant and important. And this concludes the part about significance versus relevance.